Here we go. He was a good guy, actually. All right. We are on 6-2, part 2. This is going to be the story prompts, right? So if you did the 6-1, 6-2 homework yesterday, you probably got this easy. Got to the story problems, and you could have probably attempted them. But you could have gotten to some things that are tricky, okay? I think I alluded to this on Monday, that the story prompts are going to look really nasty for this section, but they're less work than the earlier story prompts, okay? It's going to be a pretty plug and chug sort of problem. Big thing I do want you to realize about exponential growth and what makes it more important than linear growth is the fact that every time you go up, right, you go from 208 to 216.32 to 224.9, you don't just go up by 8. The reason why this is important, someday you'll have money, maybe, but what should you do with your money? You should be, your bank gives you 0.035% interest. That's not good. So if you're investing, if you're doing a percent, every time you get that percent a little bit higher, it's an exponential increase. The same is true though for a mortgage, right? Your mortgage rates, if you buy a house for about $150,000 and you get like a 6% mortgage rate, you're going to end up spending over $300,000 on your house. Like, think about that. Anyway, I digress. Also, if you negotiate your contracts, always do percent increases across years instead of flat rates, because the percent increases across years are exponential. But I digress. Let's do an equation. Oh, this equation right here is a big one. You're going to use it a lot. You've probably seen it at some point in your high school scholastic career, and throughout college, you're going to see it a lot as well. Your total is your principal times 1 plus your rate over m to the mt, where m is the number of times compounded a year. Okay? So, what's going to be better? The more things are compounded a year, the more you make off it. Okay? Most things are yearly or annually. You guys got that formula memorized? All right, good. Let's do an equation. I'm just going to write this over here for fun. A equals your principal times 1 plus your rate over m to the mt. Right? So, what's your initial amount? How much you're investing? 12,000. So 12,000 is your P, your principal, your starting amount. I'll even add that here. That's your starting. Right? Rate, that's going to be a percent, and number of times. Compounded, and this is going to be always in years then, because that's times compounded per year. Geez, you can probably not read that. I'm sorry. So again, P is your starting, R is your rate, a percent, M is number of times compounded per year, and T would be then in years. Okay? So if we are compounding monthly, how often a year are we compounding? 12. So that gives me M is going to be 12, right? P is 12.05. And then do I have a rate? 5. That's my R. Okay? So really, once I find all that, I just plug into the formula. Okay? So it's 12,000. 1 plus, now be careful, I don't use the percent, I got to use the decimal, over 12 to the 12t. All right, any questions why I put any of the numbers where I did? Okay. Compute how much will be in the account in 10 years and after 40 years. All right, let's see how much money we're going to make. 5%'s actually not terrible for a bank. So for 10 years, I would do 12,000. 1 plus 0.05 over 12. Make sure you're using your parentheses correctly. And if you want to convert that to a decimal, like first and then plug in, that's fine too. To the 12 times 10, right? Go ahead and try this if you got your calculator. Again, you got to get proficient using your calculator in this section. This is a very calculator heavy section. But I got 19,764.11. I mean, this is life advice, but guys, like I said, if your money's just sitting in a checking or savings account, makes you nothing. Even if you buy a CD at a bank, they'll give you a 10-year CD for like a 5%. What happened to your money in 10 years if you put it into that? You made almost $8,000 just sitting on your butt doing nothing. If you have mutual funds or IRAs, oh man, take personal finance sometimes. It's good stuff. Now, what would happen? Let's say I forgot about that money in the account and I live another 40 years. How much would I have after 40 years? I'm going to do the same thing, same equation. Second, enter on my calculator. And I got 88,301.01. So after 40 years, what happened to my money? I got a lot. And that's why, what should you do when you first start working? Invest early, right? Because what will happen when you go to retire? If I invested 10 grand my first year working, retire after 40 years, how much is that 10 grand worth? That's 80,000. All right, so questions on this? It looks really, really complex. Make sure you have the formula and make sure you know how to use the formula, right? Just because you can use notes on something doesn't mean you know what the letters mean, okay? All right. All right, let's do another one. All right. Do you guys mind for this one? We'll just go over how to find the equation. I'm not going to do the plugging in part. Sound okay? Because I just want to make sure you get it. So next one, we're initially starting with $1,900, my first year salary. So that's my principal, right? That's my P. There's my R. Now, what's it mean to be quarterly? 4 times a year, 4 times a year. So my M is going to be 4. Is that everything I need for my formula? You bet. So I do 1 plus 0.0275 over 4, because my M is 4, and then 4t. Okay? And then I would plug it in, my 10 and my 40. For this one, if you're curious, because I know you guys are, my rate's a lot lower on this one. After 10 years, it was 2499.06. So if later you want to go through and check and see that you're doing this right, 5686.47. Any questions on the formula though? While I'm plugging in, doing anything I'm doing, trying to pause sometimes, take a deep breath. That one grew a lot slower. Think about that. That's less than half the rate. And that one you doubled a little bit, and the other one had double the rate, and you had 8-fold the money. You know what I'm saying? Because it's exponential. You made 4 times more money with the double the percent. Anyway, I digress. Pay attention to that stuff as you get older. It makes a big difference. Refinancing, all that stuff. All right. Pert. It's a good type of shampoo. Sometimes I use Pert Plus. All right. So are there things that compound continuously? Bacteria in a dish double. they grow exponentially, right? Do they stop and say, oh, we're only going to reproduce every month? Or do they just continuously keep going? They continuously keep going. So now, is there ever banks that are going to give you continuous compounded interest? Absolutely not. But this is going to be, if you go into a science field, chemistry, bio, physics, there are things that are compounded continuously, especially population growth. So they made this not, we're going to see the number E again, the magic number. It's a limit. If you want to go into the proof why E exists, I think we did it in Calc 1 back in the day. But we use PERT. The letters mean the same thing. Starting. Now remember, E is a number on your calculator, right? R is your rate, and T is your years or time. Okay? And A is your how much you have, amount. Some books use different A, like instead of an A, they'll have a different one. Some books I used had S, and that was never use S as a letter. All right. All right, this one even has less stuff to plug in. We need to do it. All right, so let's say we took $325,000. They said they're going to give us a 5.5% growth, and they're going to compound it continuously every second of every minute of every day. All right. Well, what do? I have an initial. I have a rate. Do you need anything else for these? No, because there's only two variables, because T is going to be the other one. So my initial is 325,000. E, like my English grade, to the rate, oops, 0.055 times T. There we go. If I was losing money, oh, I think we have one of those. If I was losing money, what part of the equation do you think I would have to change or make negative? If you're losing money, is your rate positive or negative? Negative. So you put a negative by your rate. That's true for every single one of the equations. If it's losing money or losing something, your R is negative. Okay, because it's a negative percent. That does that make sense? The percent is negative. Every year you're losing a negative percent. All right, try this beast in your calculator. 1 second, let me write down my keystroke. So I'm going to do 325,000 e to the 0.055 times 10, right? And you should get 563307.23. So go ahead and give that a shot and see how you do. Beep. All right. So we got that. Oh no. And then when you do 40, what's going to happen to our money? It should get to be lots and lots of monies. I got 2 million, 2.9 mil. I'm going to donate to the Scooble Fund. Okay. So if you're having any problems with calculators, just let me know. Calculator heavy section. All right. Beep. All right, I'm going to do the same thing. I'm going to write the population growth. People project a growth rate, yeah. And then you won't spend as much time on it. So again, a city has population 45,000. What's my starting? 35,000. Whenever I see continuous growth, it's going to be an E. So populations, right? Populations are one that continuously grow. E to the 0.021 T. Yarnar. Fun fact in this city, what do you guys think the population was 20 years ago? By how much though? It was around 2,500, 2,400, 2,500. Now what do you guys think the population is? It's around 14. Oh, it's less than that. I think it's, yeah, it's something like that. So if you go back 50 years ago, I think it was like almost 5,000. We're actually on the um. Good question. It's going to go up though, and we're actually going to be on a stabilizing path. All right, this one I do want to do. So there's a county in Oregon that had 15,800 people in 1980. It lost 1.5% of its population each year. So we need to create an equation for how many people are going to happen. Now, it is going to compound continually because population does that. Again, people just don't all decide to have kids at the same time. So let's make our equation. Our equation is our initial. That's going to be an 8 times E. Now, it's decreasing. This is what I was talking about before. So what's my R got to be? Negative. That's a negative. That's a negative. That works for the money ones too. Anytime it's a decay, it's a negative R. All right. So when I predict go ahead and try to type this in. When I try to predict what the population was in 2005, I plug in how many years after 1980 is 2005? 25? I got 10,859.17. Yep, 25 is the T. And then this one you should get around 6,423.8. Now, when you are estimating a population, if you're finding a population, you should be rounding down because you have decimal. But when you estimate, when you're using regression, you are allowed to keep the decimals in place, okay? Because, yeah, you can't have 0.17 of a person or 0.8 of a person, all right?